Howdy there, Internet students. This is Mr. Hermanson helping you with Objective 6.2D. That's the objective where we learn how to write equations of lines that are either parallel or perpendicular to given equations. So we're going to start by writing equations for lines that are parallel. For parallel lines, we need the same slope. All right, and it just says write an equation, so I'm going to actually do this two ways, and you can decide which way you want to do it. Since it's giving us a choice for a type of equation, and we are given a point on the line, and we know that the slope we need to be parallel to the graph of this other equation is 6. I really have everything to write a point-slope form equation, so I could just start out. And in point slope form, we would have y minus 8. I got that 8 from right there, that y. And then my slope needs to be 6 to be parallel, and then x minus 12. All right, and you could actually change this into slope-intercept form. If it said write an equation in slope-intercept form, I could quickly just change this to slope-intercept form by getting rid of the parentheses, and then adding 8 to both sides. And so quickly we get y equals 6x minus 64. And now it's in slope-intercept form. And some people like that more elegant form anyway. It's up to you, but you could have just left it in the original form that I did there, point slope form, since all it said was write an equation. Okay. Now one other option, if you always like to put things in slope-intercept form, then you would have to find the y-intercept, and you could find the y-intercept like I just did. You saw the y-intercept at the end there, but I know some of you are used to doing it this way, so you could also do it this way, where we just substitute in 12 for x, 8 for y, and 6 for the slope, and so we get 8 equals, and then I have to do 6. 6 is my slope, and x is 12. Multiplying those together is 72 plus b. Then I would just subtract 72 from both sides, and I find that b is negative 64. And now I can write y equals 6x minus 64 for my equation. It's up to you. Do it either way you like. Okay? And on the next one here, we just have to figure out whether these are parallel, which would mean they have the same slope. Perpendicular would mean they have opposite reciprocal slopes. And remember, the way you tell if two numbers are opposite reciprocals is you take those two numbers, multiply them together, and they would equal -1. So that's the way you see if they're perpendicular, or neither. So if they don't have the same slope or opposite reciprocal slopes, then the lines are neither parallel nor perpendicular. Okay? So this equation is easy. The slope is -1/4 because we can see that's written in slope-intercept form. The bottom equation is written standard form, so I can't really tell what the slope is right now. So I'm going to change it into slope-intercept form. To do that, I need to solve it for y. So I'm going to get rid of this 2x. So I get 8y equals 6 plus 2x over here. Then we just have to divide everything by 8. And we get y equals 6 divided by 8 is, that simplifies to 3/4. Not that we need to know that for our results, but we get 3/4 plus 1/4 x. And since this one here is -1/4 and this one is +1/4, we have neither going on here. If they were both -1/4, then they would be parallel. But so we're going to say neither. Okay, so the object here is to figure out what the slopes of the graphs of the two lines are, two equations, and then compare them and see if you have the same slope or opposite reciprocal slopes. All right. On this problem, we are going to go ahead and write the equation of a line that's perpendicular. Remember that for perpendicular lines we need opposite reciprocal slopes. Okay, and I think to make this easy, I'm just going to use the point slope form. All right, so first of all, I want to check and see what the slope is here, and that's -3. The opposite of reciprocal of -3, think of this as a fraction, -3/1. I'm going to flip it over and make it positive. Because remember, when we multiply those two, they have to equal -1, which they would. So the slope I need for this first problem is 1/3. So just to make this fast and easy, I'm going to write it in point slope form. So I'm going to do y minus my y, -8, equals 1/3 times the quantity x minus my x, which is 7. And then just to make it a little prettier, I'm going to take that subtracting of the negative and turn it into a plus. And since all it says is write the equation, I'm not going to do anything more here. I think that's good enough. All right. And the last problem here, we're just given some different situations here, and we want to know if they're parallel, perpendicular, or neither, or answer the question. So this first problem here, it says Sandusky Street passes through these coordinates, which means it's some line that goes through those 2 points. Pennsylvania Avenue passes through those coordinates. Are they perpendicular? The slopes really help us tell if they're perpendicular. So I'm going to do the slope of Sandusky, which is, so I'm going to do my y minus y over x minus x, and that equals 9/2. And then for Pennsylvania Avenue, I'm going to do y minus y over x minus x there. So I'm going to do 3 minus 2 over 1 minus 6, and that equals 1 over -5, or -1/5. Those are not the same. They are not opposite reciprocals. So I'm going to say no. And my explanation is the slopes are not opposite reciprocals. All right. So go ahead and finish up that practice, and then good luck retaking that.